Welcome, everybody. My name is Tim Stewart. I run a company called Visual Decisions. With me here today, I have Thomas Stecco from Sandalwood Engineering and Ergonomics. And we're going to talk about designing IIoT native workflows, how to turn raw machine data into actionable intelligence. Welcome, Thomas.
Well, Tim, it's always a pleasure. It's nice to be back.
Always good to
Uh,
have you here, man.
yeah, no problem. Thank you so much. Just a quick note about myself. As
Yep.
Tim mentioned, Thomas Stecco. It's going to be 7 years that I'm working with the systems integration group here over in Sandalwood. I work in various projects, or I work in various projects in digital transformation, smart manufacturing, IIoT, and cybersecurity. A quick note on Sandalwood. So Sandalwood is an engineering and ergonomics professional services firm with the goal of helping you work smarter and safer. We have offices in the U.S., in Livonia, Michigan, in Mexico, and in Canada. And I am based out of the Ontario, Canada location.
Excellent. Let's see. So why don't we go ahead and dive into the presentation here today, and we'll go from there.
Yeah, for sure. I'll put a couple slides together just kind of from my experiences that I've seen in many different production environments, different types of systems that I've seen, some improvements that I've seen, and some pretty cool features that we can do uh, with some effort.
Yeah, I mean, we've been in this space for a long time. We've developed some of these workflows for customers together, and I know you've done a whole bunch of other implementations as well. So I'm anxious to see what's in the presentation today.
Yeah, thank you. No worries.
Yeah.
Yeah. So, like I mentioned, what I've seen on the floor, a lot of manufacturers, we want fast, simple ways to convert our machine data into something meaningful. Um, but if we're using an old school, traditional, or MES system or tool, it might be limited to the amount of tags, or it's too rigid. There's no flexibility. It's getting expensive to deploy and maintain. The cool thing about working in the integration group here at Sandalwood is we're software agnostic, right? So our teams, we use various types of MES and SCADA platforms. Some have their pros for specific applications, but we really don't pick and choose. It's all up to the current project. I've been tinkering the last couple of years with Ignition by inductive automation. Um, Make it possible to build lightweight applications which can consume your machine data and make it something meaningful without any complexity. There is some complexity, but the online community is super awesome. The online university is pretty cool. And you can do really custom applications. You can build custom plugins. You can go on the online store and download specific tools. It pretty much allows manufacturers to move beyond monitoring and begin acting on that data as it happens in real time. You know.
Yeah. Yeah, I've seen a lot of platforms out there. I did a lot of work with PTC ThingWorks in the past. Ignition
Mhm.
seems like a solution that is lighter weight than some of those kind of older platforms. A little bit
Uh-huh.
more nimble, and certainly, from a licensing perspective, much more affordable for a lot of different manufacturers.
I mentioned rigid, limited flexibility, right, as a previous con. And as you mentioned, if I need to use like a OPC UA server, if I need to use a third party application which connects my machine data through something, out of something, and then into my SCADA application, that's an extra point of failure, or that's an extra layer that I need to maintain, troubleshoot. validate my data in two separate systems. Cool feature with Ignition is they have a built-in tag browser. So you get your tags right inside of the platform, and then you can act on those tags. Right?
Yep. Yeah. Very nice environment to work in, where you have that ability along with the UI and everything else. So when you're putting this in place, what are some of those issues that you're really trying to address?
Can we go to the next slide?
Yeah.
It's actually approaches this question.
Yep. We should be on slide 3 with the manufacturing problem.
Perfect. Most manufacturers have that data. We got lots of data. You might be going into some sort of a relational database, Postgres, SQL, MySQL. It doesn't matter, but we still rely on manual tasks, spreadsheets, tribal knowledge in making some sort of a decision, right?
Mm-hmm.
We collect alarms, machine events, machine states, timestamps, etc. every day, but are we using that data to trigger an event or a action to tell me something, right? So I titled this IIoT native workflows. What we're trying to do is it's simply taking those machine events and turning them into a automated task. Like, let's do something with that data. I can get a notification, work instructions. Let's say I'm on a HMI that has a specific dashboard on production. I might get a pop-up or something like that to alert me, or I might even write back to the PLC and shut the machine down. So what we're really trying to do is turn meaningful data or turn raw machine data into meaningful data, right? And now we can actually use that meaningful data and calculate our KPIs. Maybe we can, make some performance improvements or reduce costs on general maintenance. If we have a robot that the manufacturer states needs its oil changed every 8 months, but you're monitoring oil pressure, oil temperature, etc. And if the numbers look okay and the color or the performance of the robot looks okay, you might be able to extend that, right? It just depends. So yeah, doing something with your data, not just letting it sit there.
Right.
Right.
So on the next slide, it's talking about what does IIoT native actually mean, and if you give us a little bit more about that,
Yeah.
That is something that I think is confusing to a lot of people that aren't into the technology side.
For sure. So let's say if a machine state changes, it goes from running to stop or faulted or idle. Or let's just say a tag, which is a property on your machine, call it torque, or an alarm occurs over temperature, over voltage, etc. That event becomes the trigger for a specific action, right?
Mm-hmm.
So let's say if we trigger a upper SPC limit for power, nominal is 1,000 watts. Cool. Min 800, max 1,200. Anything outside of those parameters, we're gonna get a fault. What do we do with this fault now? Maybe I send a text message. Maybe on your phone you get a notification that you can open and view on a dashboard that fits your phone in a responsive container immediately without being told from an operator or from a supervisor that something happened, the process is currently down, right? So instead of waiting for the operator to find that problem, the system detects that change and runs the appropriate workflow. So rather than just collecting data in a system in a database, let's make that data detect, decide, and drive action in real time, right?
Yep.
Yeah. And this is
Excellent.
what I see And it's pretty cool when you build a dashboard with some parameters, some widgets for some tanks or something like this. And then you actually see the colors changing, and then you make the operator's life so much easier. They can work more efficient, right? And it makes them a happier operator, right? It makes them a good, a solid employee, right?
Yep. Yeah. I mean, anything that you can do on the shop floor to, kind of reduce that day to day, just friction of, getting through and dealing with a lot of these exceptions just makes it easier for everybody.
Mm-hmm. 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 Yeah. Or even it's cool to get a text message. It's like,
Yeah.
wow, machine, this department, this line at this time, this column number. Uh-huh. Cool. This state code. Okay. And I can reset it from my phone. Oh, this is pretty neat.
Yeah. And then, um, we've got the workflow architecture. Um, not only getting the raw signal from the machine with that power draw and so forth that you
Mm-hmm.
mentioned, but how do we contextualize that so that what we're showing to the operator, to the supervisors, et cetera, isn't just the raw data, but it's actually what is the meaning of that information that is coming from the machine.
Let's say hypothetically we have 100 machines. They're all the same.
Mhm.
They're building some sort of a product, a white good product or something like that, right?
Sure.
It's like, wow, I have to display data for 100 machines. Like, how do I do that? Do I need to map all 100 of those machines manually? Map all the tags for, serial number, map it, bind it to this OPC UA server or bind it to this tag, etc. 100 times 10 properties. It's 1,000 clicks that I have to do. That's not very efficient. And then if I have to add another property, I got to do it a bunch more times. So how do we make our life easier? With Ignition, we can create a user-defined type or a UDT.
Mhm.
So think of it like a blueprint, right? Let's say you have power, voltage, current, serial number, manufactured, date manufactured, etc. You have all these parameters plus the parameters out of the machine, temperature, etc. We can create a UDT for compressor, one UDT, and then map our properties that we can add manually, current, power, torque, voltage, etc. And then use the property machine number as a variable in our path. So now it doesn't matter if we have 3 machines, 5 machines, etc. Each machine becomes a instance in Ignition. So it would be line 1, machine 01 / X, line 1, machine 2, etc. So we can make our data in a common model, enrich that data. And now that we're set, now we can actually view that data in some sort of a dashboard, make it look kind of cool. Make it so now, okay, the backend work is now done. It's all mapped. Great. Now let's show the operator, let's show the supervisor something.
Right.
Right.
And um,
Mhm.
kind of the next step here is thinking through why this event driven approach matters as opposed to, just a lot of like historians will capture just these long time series, of information and so forth, but don't really capture necessarily the events that are happening. The machine went down at this time, it came back up at this time, et cetera. And so talk through why that event-driven architecture matters.
So the traditional systems often collect a lot of data, right? And now we wait for someone to tell us what to do. They got to decide, we're getting a lot of rejects, or we're getting a lot of scrap, or this is not passing our caliper checks with our vernier gauges or something, right? The approach looks at, let's say we get a machine fault. Let's say we get a code of 996, which means e-stop latch X. But if we have those 100 machines that we discussed earlier that are all the same, and they should have the same fault codes, the same warning, the same type of dictionary. It's like, aha, we can create a UDT for faults based off of the code. 776 might be a specific code. And now we can do something with that specific data. So let's say the machine is running and it stops or it's idle for more than 5 minutes. Anything, we can create an event or a trigger inside of ignition. And like I mentioned earlier, our light flashes, a stack on the actual rack will go from green to red, right? We can do a lot of work with state codes rather than clearing them because they're annoying. Cool, let's do something. If that code hits 500 cycles, if I reach more than 500, now let's send an email to the process coach or something like that, because now there's something happening. People need to get involved, right?
Yeah, and it's not just uptime, downtime on the machine or a fault code coming from the machine. You kind of alluded earlier to the power draw and kind of a condition-based maintenance approach where if I've got something that's exceeding the limits or the tolerance or anything else, I don't have to get a signal from the machine itself saying, hey, an event occurred. I can create an event based on some of those signals within ignition itself, right?
Correct. Yep. Very, very good point. That's a excellent feature that you can control. You can control those parameters for what you want it to do.
Right.
Right. If it's a separate department, you might have to tweak some of those variables, but it's 100% possible, and it just makes it much more efficient.
Yep.
Mm-hmm.
And so, let's talk about some of those design patterns. You talked about putting this into a plant that has a lot of, the same types of machines and so forth. At the extreme end, I've been in, without using any brand names, I've been in a plant where they make the toy cars, and they made a lot of
Hot
them.
Wheels?
Maybe. I'm not naming names.
I collect them.
And they had hundreds of machines of the same type because they make such high volume of those. And so, how do you set this up so that you take one machine, you build those patterns and so forth, and then you can reuse it across that whole set of 200 plus machines that they had?
And we're not always going to have a perfect world where all of your machines are the same. You might have 7 departments, 25 departments that might have a group of 7 that are the same. Cool. That's going to be its own group. Bam. Right. Then you might have another group that has 25 machines that are all the same. Okay, cool. Or you might have a bunch that are just unique. No problem. It's a little bit more effort, but you still get the same results. You just got to put in the time. Right. So the way that I look at it, so I don't want to configure alarms manually. I don't want to waste time. I don't want to write project scripts manually for maybe 25 different variables. Maybe I can do a global project script. I don't want to create a dashboard for um, every asset, right? I would rather have all the assets show up without me having to drag 100 asset widgets onto my canvas and then mapping them all, mapping all the custom properties. I don't want to do that. It takes too much time. There's better ways to actually do it.
It's a maintenance
Utilize.
nightmare too.
Well, yeah. And then if you move on as a developer, someone has to look at that and be like, I don't know what's going on. Like, okay, this is going to take time. Why are they doing this? Why are they doing that? UDT, get the UDT set up. If you have a machine that has common parameters, we can create a UDT, map it to a variable called machine num or machine number or something like that. And now if we change the path to a 10, or if we click on a motor, that might be the 9th one, and a pop-up opens, since I have that parameter map to machine number, a pop-up comes up with advanced data for that asset. UDTs, machine states have to be common. So if I have PLCs, 100 PLCs, 10 PLCs, all running on my assets, they should have the same tag path, the same quality if they're on the same network, etc. So I'm like, okay, if I can define, make it clear, a fault means that this tag plus this tag and or this tag, if true, equals faulted or something like that. If we can confirm with all these departments that, hey, guys, we're not changing our minds after this. Like, once we set this up, this is how it flows. Cool. If everyone agrees, we got that down. When we're designing these, and now we want to show 100 of these motors on your phone, I'm not going to drag 100 widgets. I'm going to use a template repeater, which is just one. And in my browser cache, if I load onto my main dashboard or home or like master, however you map a button, it's going to now make X num equals 100. So now all 100 of those assets show up, but I only map one widget, right? I saved a bunch of time. Right? And this is a cool feature that you can do with the platform here.
Excellent.
Yeah.
Let's talk about kind of interpreting that information once you have it in. So you've gone through, you've set up your UDTs, you've got that tied into your naming conventions and so forth. And now you've routed that information. Let's talk about how to put some analytics and so forth in place that are make it easier for people to determine what's going on.
So you think of analytics, you think, ooh, that's difficult. Ooh, I need someone smart for that, or I don't know, like, what can I do? Not every process needs any type of analytics, large or small. It just depends on the application. If we can track downtime frequency, fault duration, microstoppages, idle, operators, teams, they can identify reoccurring issues and we can act on them. Maybe I hit a button on my HMI, opens up a text box or something like that. Or I might be able to go on my phone, type in a comment, upload, and now for that event, it's going to map it to that asset at that station in this department with this comment. We can do something like this. If I'm looking at it at a business approach, I can supply availability, performance, all of our KPIs to management staff, real-time data that is updated every 5 minutes, every 10 minutes, every hour. You can have a date select widget. So let's say I want to look at the last 6 months. You get your KPIs, your performance, your overall availability, and then you can see how your process is actually running year on end to see if there's more downtime, if there's more maintenance, what processes might need X amount of cash flow to improve PLCs, improve the keyboards, something like that to make the process a lot easier. So the goal isn't more data, it's delivering that data to the right people at the right time.
Excellent. So in terms of ignition and how it fits into all of this, Let's talk about some of the workflow and deploying Ignition and the different things it can tie into here.
I think this is the last slide here. So at the end of the day, if we can turn machine events into automated actions, we can respond to those issues faster.
Mhm.
We don't need manual effort. I don't need to sign a piece of paper with my name, my last name, my shift number, my badge number, what happened, what time. Hopefully someone's going to read it. Because the solutions are built on reusable patterns, we can deploy these quickly, scale them, and maintain them with less engineering effort. And it's easier for a new developer or a young developer to jump onto a project, create a sandbox where they can go in there, copy or make a clone of a specific project, and then they can go ahead and add different types of variables to those projects, right? The
Yep.
cool thing with Ignition is, yeah, you have perspective where we have all of our widgets. You have your tag browser project scripts, global scripts. But there's like a lot of cool home automation, cooler projects that you can do, even with the Maker. If you look up the Ignition Maker edition there, you can just mess with it yourself for 100% free, right? Just to see what you can actually do with it. So it's built in a way that you don't need to be a software developer or someone that has a lot of IT knowledge on the back end to actually get started, right? So we get better traceability, faster execution, measurable results that the operators, the supervisors, and the management teams will see, right? And then if they have feedback like, hey, it would be unique if we had this feature, or if this happened, it would be so cool if the forklift driver got a message on his phone that my bin is full. It's like, okay, we can do
Right.
it.
Yep.
Yep.
Okay. So what are some of your key takeaways?
Machine data only creates value when it drives action, when it does something, right?
Yep.
These workflows, they bridge the gap by connecting events to people, processes, and systems in real time. If we could put it all together, ideally, we can enable faster responses, better visibility, and scalable operational improvements, right? So then I can take this beta project or this feature that this plant has. There's a sister plant. I might have different equipment. They might have something different, but it's like, hey, look at these trend charts that we've been getting the last 8 months. Now we can focus on this line, and yeah, the operators are onto something. We are seeing a slowdown in progression. Let's say if it's a stamping plant, or the amount of
Right.
cycles, the amount of hits, something is going on, and look at the data. Data is quickly going down, right? It's just taking that data and just doing something cool with it, right? Make it meaningful.
Awesome. I guess that's all we have for today. Thank you very much. Any final words?
Oh, it's always a pleasure, Tim. I like the theme of um, really looking at the audience. Not everyone is going to be a software developer or someone related to IT, but just knowing the fact that there's tools out there that can maybe make your life easier, that can improve something, that can prove a point, right?
Yep.
And then that can be forwarded on, right? Hey, I heard about this software. Check it out. I was on the YouTube channel. I was having a look on how they connected a SQL database right to the platform, and it showed me how to set up the path, and it worked. you know.
Yep.
Yeah.
All right. Well, thank you very much. I think we're at our time here, but
Yep.
Thomas, always a pleasure to have you on. And, we'll, I'm sure, talk again here pretty soon.
Sounds good, Tim. All the best. Enjoy that weather today. It's gonna be a hot one.
That's right. You too. All
See
right.
ya. Yeah. Bye bye.